All right, let's spend a few minutes walking ourselves through the quadratic formula, and don't feel bad if this takes you some practice to get down. This is just one of those things that there's a lot of details involved, and a lot of times the frustrations don't come from the setup, they come from the mechanics involved in just simplifying it. Now, this big old formula you see here, don't let this bug you. Okay, I know there's a lot of stuff there, but this is really our backup plan in case all of our simple shortcuts that you're going to work on this semester don't pan out and you get some ugly solutions that you just wouldn't know off the top of your head. This is what we kind of fall back to. So we're going to start by practicing this. We have A, B, and C in our equation. This quadratic formula just has all three of them in different places. C only shows up once. What we need to do is notice that that just represents these numbers, 1, 8, and 6. Okay? And the negatives and positives must go with them. So rather than worry about the x's, we're just going to worry about those coefficients. So this is A, this is B, and this is C. So start this problem by just putting the numbers where they're supposed to go. If you try to do this in your head without writing it down, it's usually a recipe for disaster. So I'm going to write x equals, it says negative b, means the opposite of b. So that would be negative 8 plus or minus square root of this part right here. That's 8 squared, not 8 times 2. So watch out for that. 8 squared minus 4 times a, which is 1, times c, which is 6. Okay. All over 2 times a, which is 1. So you start by just getting the numbers in the right spot. Now we have to correctly evaluate this thing. So let's start with the discriminant, this part here on the inside. Okay, work your way through that. I'm going to continue to write the other stuff just to remind you that it's there. So we have negative 8 plus or minus square root of 64, remember not 16, minus, and then that stuff just gets multiplied together. That would be 24 all over 2. 2 times 1 is 2. Now let's keep on going. That gives me negative 8 plus or minus square root of 40 all over 2. And you guys spent a lot of time working with radicals like this that weren't nice whole numbers on ways to simplify them and write them just in a different fashion. So that would end up being square root of 4 times the square root of 10. Keep in mind, I'm ignoring the 8 and the 2 right now, just taking care of the radical. That's actually 2 square root 10. So if I eliminate that and put this thing in its place, I get negative 8 plus or minus 2 square root 10 all over 2. And now I notice there's some whole numbers. This right here, just leave it alone. That's a decimal. It goes on forever. You don't know it. Don't worry about it. But 8 and 2 can all reduce. They can all divide by 2. This becomes negative 4, 1, and 1. So this whole thing becomes negative 4 plus or minus 1 square root 10 divided by 1. And if you've been in math long enough, you realize that multiplying and dividing by 1 really don't matter. I mean, it doesn't change anything, so we don't really have to write it. We can just write this as negative 4 plus or minus square root 10. You can't always write that simple, but in this case we can. Now, a lot of people get to the end of that and go, what in the heck did I just do? I may have done the math right, but I have no idea what this means. Keep in mind, this is 2 answers. This is 2 decimals you probably do not know. You shouldn't know off the top of your head. The first one is negative 4 plus square root 10, which is going to be some decimal, a little less, a little on the negative side, a little less than 0. And then you're going to have negative 4 minus square root 10, which is going to be even more negative. Now those decimals, whether you know them or not, they really do represent something. So I want to show you what that is. If we were to graph this parabola, you would see it look maybe something like that. And those decimals right here represent the places where this thing touches or crosses the y-axis. Okay? And those are kind of important as we move on in the analysis of these quadratic functions. Those spots right there have a lot of different words. Okay? They're called roots. They're called solutions, which we have been using that terminology right now. They're also called intercepts. They're also called zeros. Okay, there's a whole bunch of words you'll see show up in algebra that all basically mean the same thing. And we can find these spots, which are really critical when it comes to applications of this type of equation. We can find those spots using the quadratic formula. It certainly isn't the easiest way. I mean, look at this mess. Okay, it's not my first reaction. It's not my first instinct to use this. We're going to learn some other ways like factoring and things like that. But if it doesn't work out nicely with what I'm using, I sort of fall back to this method when I have to. So there's the basics on the quadratic formula.